want to start off with that distinction between reactions and equations. And saying they're the same thing is like saying that the furry thing that just came up and licked your kneecap is the same as this. One is the actual thing, one is the word that represents the thing. So it's like the concept and the word for it. And that's exactly what chemical equations are. But we do a lot of math with them. So they are kind of important. So in the video that you watched, we left off with this. And now we're going to fill in the details on that just a little bit. How long was that paused? Okay, so chemical analysis, reliable sources such as your book or your instructor. Okay, you have to have correct formulas for both reactants and products, and this is the thing that trips most people up. And I'll tell you right now, this is where mistakes start. So you're at this point pretty good at writing a formula when I give you a compound. Iron 3 sulfate, and you go, okay, let's see, Fe3 plus, SO4 2 minus, Fe2, SO4 3 times. You're good at that. Here's where people trip up. Because what you're gonna start getting is a sentence that describes a reaction, and from that you have to write down an equation. And we're gonna go through a stepwise process. The ones that trip people up are things all on their own. So if you had Mr. Voorhees for physical science, he talks about the heavenly seven. And it's the 7 elements that are gases at room temperature, and they're all diatomic. They never walk alone. They always are holding hands with their twin. So the heavenly 7 are, let's see if I can do this without looking, O2, N2, H2, F2, whoops, Cl2, 1, 2, 3, 4, 5, Br2, I2, 1, 2, 3, 4, 5, 6, 7. Okay. And iodine is actually usually a liquid at room temperature, but we ignore it. It's diatomic. So if you're told that you have chlorine gas or fluorine gas or nitrogen gas or hydrogen gas, that's appearing all by itself. It's not part of a compound, which means it's diatomic. And if you screw that up, your equation will not balance. So that's the first place to screw up, is the things that are diatomic. The other part that is commonly an issue are the metals. And I think I gave you my impression of the individual I call Scary Metal Guy. There's my best attempt at drawing Scary Metal Guy. He's smiling. He shouldn't be smiling. He should look enraged. Those are supposed to be Liberty spikes. It's not a dinosaur. He walks alone. He holds hands with nobody. He's a scary metal dude. So those metals are always alone. So if you're told in an equation, in a reaction, that you have magnesium metal, zinc metal, iron, copper, anything that's a metal, you don't usually see things like sodium, potassium, lithium by themselves because they're so reactive they tend to not exist by themselves. But we see chunks of iron or copper or magnesium or zinc all the time. So those are important to remember because, you know, they always are by themselves. If you put down Fe2, again, your equation isn't going to balance and you're wrong. And the last two that are weirdos are sulfur and phosphorus. And sulfur, for some absolutely unreasonable, incomprehensible idea, exists in the wild as S8. They form little bundles of 8 copper atoms. If you forget that and you just put S, it doesn't balance. Hey, I'll see you tomorrow.